Hello friends. Today we discuss about the topic embedded system. First we think what is the difference between system and embedded system. System is a way of working or doing one or many tasks according to a fixed plan or program or a set of rules. An arrangement in which all units are assembled and work together according to a plan or a program. An embedded system is a combination of embedded hardware and embedded software which dedicated for a specific task. The task has to be completed in a given time. Embedded systems are founded in a variety of common electronic devices such as consumer electronics, office automation, home appliance, business equipments, automobile, etc. The main aspects of embedded system are real-time operation, time, size, reliable, safety. All embedded systems are task-specific that are created to perform the task with a certain time frame. Embedded systems are built to achieve certain efficiency levels. They are small size, can work with less power and are not too expensive. The hardware of embedded system is used for security and performance. This is the flowchart of basic structure of an embedded system. It contains sensor, analog to digital converter, processor, digital to analog converter, actuator, and memory. Sensor. It measures the physical quantity and convert it to an electrical signal that can be read by an observer. ADC. It converts analog signal sent by the sensor into a digital signal. Processor and ASICs. Processor processes the data to measure the output and store it to the memory. DAC. Convert the digital data fed by the processor into an analog data. Actuator. Compare the output given by the DAC to actual output stored in it. Memory. Memory is used to store the code in a chip. Constraints of embedded system are system memory, processing speed, limited power dissipation. System memory is an standalone memory. It is an integrated on-chip memory that supports the logic code to accomplish the intended function. Optimizing embedded system for low power consumption requires developers to find a balance between performance and power usage. However, achieving this balance can mean compromising product capability and reliability. Next, we talk about what are the characteristics of embedded system. Single function, tightly constrained, reactive and real-time. Single function, it executes a specific program repeatedly. Example, printer. In contrast, desktop systems performs various programs such as spreadsheet, video gamer, etc. Then tightly constrained. All computing systems are constrained in their design metrics, but for embedded system have tightly constrained design metrics. Reactive and real-time embedded system. This must continuously react to the changing system environment and must compute result without delay. This is the figure of development cycle of an embedded system. The steps in development process are determine the requirements, design the system architecture, select the operating system, choose the processor and associated peripheral, choose the development platform, code the application and optimize the code, verify the software on the host system, verify software on the target system. Next one is processor in an embedded system. Processor is the heart of an embedded system. It is a basic unit that takes input and produces an output after processing the data. Processor in a system has two essential units, program flow control unit and execution unit. The program flow control unit include a fetch unit for fetching the instruction from the memory. The execution unit has the circuit that implement the instruction pertaining to data transfer operation and data conversion from one form to another. Types of processors. Processors can be of the following categories: general purpose processor, application specific system processor, application specific instruction processor, application specific integrated circuit. Microprocessor. Microprocessors are multitasking in nature, can perform multiple tasks at a time. It have RAM, ROM, IO ports and timer. The designers can decide number of memory or IO ports needed. Microcontroller. It is a single task oriented, contain RAM, ROM, IO ports and timers, cannot be added externally. These components are to be embedded together on a chip and are fixed in number. Fixed number for memory or IO makes a microcontroller ideal for a limited but specific task. Architecture of processor. The architecture of a processor is a description of its basic components and of the basic operation. It depends upon the power and the memory. There are two types of processor architecture: von Neumann architecture and Harvard architecture. Von Neumann architecture was one of the primitive architecture. At the time of its invention, the computer program were very small and simple and memory cost was very high. Under von Neumann architecture, the program and the data are stored in the same memory and are accessed on the same bus. In Harvard architecture is a modification over von Neumann architecture. It separates the data path exists to access the code and data. This makes it possible to fetch instruction and data same at a time. IC technology. IC stands for integrated circuits. It is a combination of various electronic components on a single silicon chip. It is formed by depositing many layers of semiconductors as per the requirements. Next, we are going to study architecture of embedded system. The architecture of embedded system containing following parts: hardware, operating software, application. This is the basic architecture of embedded system. Input and output are the characteristics of an open system, and the embedded system is no exception. In the embedded system, the hardware and software often collaborate to deal with various input signal from the outside and output the processing results through some form. The input signal may be a device such as keyboard, mouse or touch screen, or the output of a sensor circuit in another embedded system. The output may be in the form of sound, light, electricity, or another analog signal, or a record or a file for a database. This is the image for embedded system hardware. The embedded system has various systems combined like power supply, input devices, processor, timers, interrupt controller, program memory and data memory, serial communication ports, parallel ports, output interfacing, system application, specific circuit. We know embedded systems are the combination of hardware and software. There are different hardware components like power supply, processor, memory, timers and counters that make the embedded hardware. First one is power supply. Power supply is an essential part of an embedded system circuit. An embedded system may need a supply of 5 volts, or if it is low power then maybe 3.3 or 1.8 volt. The supply may be provided with the help of battery. Next one is memory. Memories are of two types: random access memory and read-only memory. RAM memory is volatile memory and is used for temporary storage of the data, and the selection of it depends on the user need and the application. ROM memory or code memory is used for storage of the program. Once the system powered, the system fetched the code from the ROM memory. Input and output devices. To interact with the embedded system, we need input. The input may be provided by the user or by some sensor. Sometimes some system need more input or output, so the processor selection will be based on I/O. The I/O need to be configured for input or output based on the provided register, and for what we need to refer the datasheet for the manufacturer. Next, timers and counters. In some application, we need to generate some delay. But there is some issue when we generate the delay from normal coding style by making any loop running for a particular time. For such kind of application where we need a delay for specific time interval without affecting the normal code execution, we use timer and counter. By setting some register for timer and counter using the programming, we get the desired delay. The amount of delay depends on the system frequency and crystal oscillator. Communication ports. Embedded system hardware has different types of communication ports to communicate with other embedded devices. Different communication ports in embedded system are UART, CAN, SPI, I2C, USB, Ethernet. But for a small level of embedded system, microcontroller has on-chip communication ports. For sending data from one port to another, we can use serial protocols, but for that we need to program it. Application specific circuits. Some hardware components are common while designing the embedded system, but some are different and depends on the application needed. Like a temperature sensor need a temperature sensor for sensing the temperature, while other hand an alcohol detector has a sensor to detect alcohol level. But the remaining hardware components might be same like power supply, processor, display device, buzzer for alert. Once the hardware is completed, we need to build the software for the embedded devices. There are different software tools for programming and coding. These software tools are referred to as software components. We need a program written in assembly or in embedded C language, and then we compile it. The compiled code converted into hex code. The hex code is programmed for burned into ROM of the system using some programmer. The tools used for this software is assembler, emulator, debugger, compiler. First one, assembler. When you program in assembly language, this assembly language program is converted into hex code using this utility. Then using some hardware called as programmer, we write the chip. Emulator. An emulator is a hardware or software tool that has a similar functionality to the target system or guest system. It enables the host system to execute the functionality and other components. It is a replica of the target system and used for debugging the code and issue. Once the program or code is fixed at the host system, it is transferred to the target system. Debugger. Sometimes we are not getting expected result or output due to errors or bug. There are certain tools that are specifically used for the debugging process where we can see the control flow and register value to identify the issue. Compiler. A compiler is a software tool that converts one program language into the target code that a machine can understand. The compiler basically used for translating the high-level language into low-level language like machine code, assembly language or object code. C, C++, Java, Python, etc. are the programming language used in embedded system. Operating system in embedded system. An embedded operating system main job is to run the code that allow the device to do its job. The embedded operating system also make the device hardware accessible to the software that is running on top of the operating system. An embedded system is a computer that supports a machine. The types of operating system: single system operating system, multitasking operating system, rate monotonic operating system, preemptive operating system, real time operating system. Types of embedded operating systems: single system control loop. Single system control loop is the simplest type of embedded operating system. It is so like operating system, but it is designed to run the only single task. Multitasking operating system. As the name suggests that this operating system can perform multiple tasks. In multitasking operating system, there are several tasks and processes that execute simultaneously. Rate monotonic operating system. It is a type of operating system that ensures that tasks run in a system can run for a specific interval of time and for a specific period of time. When it is not ensured, there comes a notification of failure to system software to take suitable action. Preemptive operating system. A preemptive operating system is a type of multitasking operating system that interprets the preemptive predominance for a task. A higher priority task is always defined and run before a lower priority task. Real-time operating system. A real-time operating system is the one which serves real-time application. It processes data as it comes in. The time requirement for processing or operating system are usually measured in shorter increment or in 10 seconds. They may be time sharing or driven by events. Advantages of embedded system: small size and faster to load, more specific to one task, easy to manage, low cost, spend less resources. Applications: home appliance, office automation, security telecommunication, instrumentation, aerospace, banking.